Alright, so we're getting into Unit 1, Lesson 5, and we're going to be solving mathematical and real-world problems with equations. Alright, so we're going to be doing two steps of equations using the distributive property, two steps of equations with real-world context, and relate the solution of an equation representing a real-world context. Yeah, so that's pretty much the same thing there and there. Alright, so let's warm up with a refresher here, and it's like, hey, we want to see which one of these expressions up here are the same as this here, right? So let's kind of see what this here, let's distribute this here first, okay, to see what this ends up being, right? So if I distribute, remember this negative sign is attached to the 2. That negative sign belongs to the 2, and the 2 belongs to the negative sign, right? So we distribute negative 2 to the x, making it a negative 2x. And then this positive belongs to that 3. They are welded together. So we're going to distribute the negative 2 to the positive 3. So negative 2 times positive 3 is negative 6. Right? So this expression is negative 2x minus 6. Right? So we're going to try to see which one of these expressions equal this. Which one of these expressions are equivalent to this when we're all said and done. So let's look at the first one. This first one here. Okay, well, let's see. Negative 2 times x is negative 2x plus 3. Nope, that one is not the same. All right, so now let's distribute this negative 2 into both terms, like that. So negative 2x, negative 2 times a positive 3 is minus 6. So that one is the same. Negative 2x minus 6. So this one is a yes. Okay, so look at that. That one is telling us that is the negative 2 minus 6. That's the same. All right, so how about this one here? We have a negative 2 times an x is negative 2x, and negative 2 times a 3 is minus, it's going to be plus a negative 6, right? Making this negative 2x minus 6. Right, which is the same. So this one is true, right? And then we have this this one, which is negative 2 plus x times negative 2 plus x, which is negative 2 plus x. Oh wait, no, I misread that. I thought this was an exponent, but it's not. That's just 3 times negative 2x, right? So let's distribute this to here, which is negative 6, right? Because 3 times negative 2 is 6, plus 3x, which is not the same. Okay, so that's a good warm-up here. That's distribution. That is the distributive property. All right, so let's go ahead and rewrite. Okay, so use substitution to show the expression which we did, right? Use a substitutive property to show that. So we're gonna let x equal 1, okay? And we'll say, so negative 2 times 1 plus 3. And so we just say let x equal whatever, right? So 1 plus 3 is 4 times negative 2. It's going to equal 8. All right, so we can do that for each one of these. Okay, so for this one, it's going to be 1 plus 4 minus 2, which is going to be 5. Hold on, 1 plus 4, which is going to be 5. Times a negative 2. Excuse me about that. So it's going to be 5 x plus 1 times a negative 2, which is going to be, it's negative 8, excuse me about that. So this is going to be 1 plus 4. 1 plus 3, excuse me about that, 1 plus 3. That was a transcription error. Transcription error, not a 4, but I added it in my head quickly, and then I transcribed it wrong. 1 times negative 2, which is negative 8. So that's check. All right, and then we have negative 2 times 1 minus 6. Right, so this is going to be negative 2 minus 6, which is negative 8. And then we have negative, let me put like a spacer, negative 2 times 1 plus negative 2 times 3. So it's going to be negative 2 minus, because this is going to be plus negative 6. And then if you add the plus times the plus minus negative, which just becomes a negative. So this is going to be negative 2 minus 6, which is the same as equals negative 8. Right? So that proves all of that. Okay. So let's rewrite each one of these. Right? So let's redistribute this 4. Let's do the 4 into the x, and then the 4 into the 6. Right, so this is going to be, our x term is going to be negative 4x, and then our constant term is going to be plus 64. Okay, so or you can be like 64 minus 4x if you don't like the negative starting the expression. Okay, there they are equivalent. But this is, you could. Nope, that would just undo what we just did. Okay. All right. So the next one is going to distribute the variable term, and then we're going to distribute 3.5 to the constant term. All right. So 2 times negative 3.5 is negative y, negative 2y times negative 3.5 is going to be negative 7y, right? And then negative 3.5 times negative 7, so 7 negative times 3.5 negative equals 24.5. It's going to be positive 24.5, and if you don't like the negative sign starting your expression, you can just flop them. 24.5 minus 7y. That 7y is wrong because it's not 2.5, it's 3.5. I just figured out I multiplied that way wrong. Wait, no I didn't. 3.5 times 2 is 7. I was right. That was the first time. Okay. All right, now we have a fraction. Oh man, fractions. All right, so let's do our 7/8 times our constant. All right, so a fraction. This is, remember, 7/1. Right, so it's going to end up with a fraction on the bottom, the 8th on the bottom, and 7 times 16. So 7 times 16m is 112. 112m divided by 8 equals 14. So this reduces to 14m, right? Minus, now our constant is going to be, if you didn't follow that, right, this is 112m over 8, right? And that becomes 14. You didn't see any of that because I was here. So 112, because 7 times 16 is 112. There's our numerator. 112 over 8, right? 112 eighths equals 14, right? So that's where this came from. And then our 4/5, you just multiply the numerator and you multiply the denominator. And this is negative, right? So it's going to be negative 7 times 4. 7 times 4 equals 28. 28, 4 times 5 is 40. Oh, sorry, 8 times 5 is 40. So 8 times 5, double check, is 40. So this is 28/40, which ends up being 7/10. minus 7/10. So that's how you're going to do that one. Okay, so let's see if there's anything else in here that's really worth going over. Oh yeah, we got to do a real world situation. Okay, here we go. Equations can be solved more than one way. Okay, it can be solved by either distributing first and then dividing both sides by a. Right, so here's an equation. Right, these were expressions. Difference between an expression and an equation is expressions don't have equal signs. Equations can have expressions on both sides of the equal sign. This one just has an expression on both sides, right? So this time we can, you can do it one way or the other, right? We have an expression on both sides, and it's saying, hey, we need to solve this equation, and you can do it, apply the distributive property first, and then divide, or we can divide and then do the distributive property, right? So to apply the distributive property first and then divide, it would look like this. Okay, so it's going to be, we're going to carry that 65 down. Let's do constants as purple. 65. I need another color for. Where'd my blue go? There, it's blue. 65 equals, and then it's going to be 8 times 9, 72 I believe, but always check. 8 times 9 is 72. 72 minus 8p, minus 8p, right? 8 times 9 is my constant term, and then 8 times p is my variable term. Okay, so now I've gotten rid of my distributions. Okay, and now I have this p to get rid of. Okay, I always like to make my variable term positive. Okay, so in order to do that, I need to balance my scales. Right, imagine I have my scale. This is this one side of the scale, this is the other side of the scale, and my equation is the center point, right? So I need to, let's see, that's my scale. Yeah, that's my scale, right? So I need to balance my scales. So in order to get p positive, right, I need to add 8p to each side. Or I just need to move it from this side to this side, and when I do that, it changes it from negative to positive. Either way, let's do 8 plus 8p plus 8p, right? So that goes there, and then, or this comes over here and turns it into 8p, right? Either way, I get plus 8p. I don't have to write the plus, right? Minus or plus 65 equals 72. All right, now I got my variable positive, and I need to move my 65 over to this side. To balance my scales, I need to subtract 65 from both sides. Minus 65 on this side, minus 65 on this side, or you just move the 65 over to here, and you flip the sign, right? So it's going to be 8p equals whatever 72 minus 65 is, which is 7. All right, so 8p equals 7. All right, so in order for me to weld or unweld this 8 from the p, I need to divide 8 from both sides, right? So I divide 8 from that side, divide 8 from that side, the 8's go away, and I'm left with p equals 7/8. Okay, so that's a pretty straightforward way to do it. I like to do it that way. I like to clear all of the stuff first, all of the variables and all the brackets first. Okay, this is the way to do it if you want to divide both sides first. Okay, I want to get rid of this 8. Right, so in order to get rid of this 8 first, I'm going to divide both sides by 8. and I'm left with 65/8 equals 9 minus p. All right, let's make my negative p orange to differentiate it as the variable term. Okay, so what is 65/8? Can I reduce that? 65/8, yeah, that is 65/8. I don't think I can reduce that anymore. Yep, that's 65/8. So it's going to be 65/8 equals 9 minus p. Okay, so now I got to convert 9 into eighths, right? So this is also 65/8. 65/8 is 8 and 1/8. Okay, so this is going to be equal to, we'll call this 8 and 8/8. All right, because that is 8 and 8/8. All right, because 8/8 is 1/8, right? And it's going to be minus p. Okay, so now I'm gonna, because it's 8 plus 8/8 is 9. Okay, so now I'm going to make this p over here. I'm going to make it positive just like I did before. So it's going to be positive p. Okay, that went over there, turned it into positive p, right? Is going to be equal to, and now I need to move. Since I added p to both sides, it subtracted it from that side. Now I'm gonna take this. Well, I'll just go. Let's not skip a step. Plus 8 and 1/8 equals 8 and 8/8. Okay. All right. So now let's get this 8 and 8/8 here. So we're gonna have p plus equals 8 and 8/8 minus 8 and 1/8. All right, well, the 8's go away, or you can convert this into an improper fraction. 8 and 8/8 equals 9, or what is it in improper? I guess it says, it's let's see, they do it in 8/8. Okay, well, if you do 8 and 1/8, do a fraction to decimal, and it's 65/8. So this is 65 minus 65/8, right? So this must be 66/8. 66/8. No, that's not right. Let's see, 9/8. No, it would be 8 times 8 is 64. 64 plus 8 equals 72/8. 72/8 is 9. Yep. So this is 72/8. See how I did that? In order to turn this into an eighths, it would be 8 times 8 is 64 plus 8 is 72/8. Okay, so you could do it that way. Either way, you can say that the 8's cancel out, and then you have left 8 minus 1, and you have 7/8 equals 7/8 left. Or it's 72 minus 65, which is 7/8, which is 7/8. Okay, so that's how you do that. All right. Now, to verify your solution was correct by substitution, you just, like we said in the very beginning, you just say let p equal something, and you go through and you say, well, let's say let p equal, we'll say let p equal 7/8, because that's what we figured out p was, right? And we're going to go 65 times 8, equals 65 times 8. Let me erase this. 65 times 8 times 9 minus 7/8. Okay, so we're going to do 9 minus 7/8 equals, we're going to multiply that by 8, and we get our answer, 65. That's how you check your answer. You figure out what you take what you solve for P, you plug it back into the equation, and it should be what the original thing said it was on that one side of the equation. Okay? All right. So I think that here's a real life situation. The perimeter of an equilateral triangle. Remember, an equilateral triangle is a triangle with 3 equal sides. Okay, is 41. So this plus that side, and those are the sides, not 1 plus 1 plus 1. It's these little hash marks represent these sides, equals 41.46 inches. Right, so you could say that 41.46 divided by 3 equals each one of those. Okay, the length of each side of the equation is Q minus 5.7. Q minus 5.7. The equation 3 times Q, so 3 times Q minus 5.7 equals 41.46. So can be used to find the value Q, right? So what is the value of Q? All right, so how can we build an equation? All right. So there's a lot of different ways we could figure this out, but what is the easiest? Well, what did it tell us? Okay, well, 3, we know that this is one side of the equation, or is one line. This is one length of that, right? And we know that 3 lengths of this equals that, right? Well, right there is our equation, right? That's the equation that we can use to solve Q. Sorry, so 3 times Q minus 5.7, they didn't even make us do anything difficult, equals 41.46, right? So now we just need to try to solve this equation. So let's distribute. I like distributing first. Let's do 3 times Q, which is 3Q, minus 3 times 5.7. 3 times 5.7 equals 17.1. 17.1 equals 41.46. All right, so our Q is positive. Let's make this Q. So 3Q is positive. All right, our variable is positive, so we don't have to move Q around at all. All right, so I'm going to go ahead and just keep 3Q there. So 3Q, and I'm going to have to move this to over here, and that's going to add it to 41.46, right? Because this negative sign, remember that negative sign is attached to 17.1, so it's going to be equals 41.46 plus 17.1. So 3Q is going to be equal to 41.46 plus 17.1. 17.1 equals 58.6. 58.56, excuse me. Right, so now all I have to do is take both sides, divide it by 3 to get rid of that 3. I'll divide that by 3, and I have that Q now equals 19.52. Okay, so you just take 19.52, throw it back into here to check that answer. Let's go ahead and do that. So 19.52 minus 5.7, multiply that by 3, and we have 41.46. So we checked it to make sure it's good. All right, let's see if we have time to go over that. Okay, all right, so hopefully that makes all sense. We're at 25 minutes, and that's as long as I like to keep these videos. If you have any questions, please let me know.